Hi, I'm Aditya. Today we'll talk about Android software stack. You can check out my profile at www.practicalcoding.in/adityak. So let's get started. So what is Android? So Android is basically a software stack. So it is basically built primarily for mobile and tablet devices. So it contains a whole set of software components starting from the OS kernel, system libraries, application frameworks, and Android specific frameworks, etc. So when you start developing Android apps, you basically start off with Android SDK. So you can download Android SDK from the Google website and you can start creating Android apps. So the Android SDK, what it consists of? So SDK is an abbreviation for Software Development Kit. So Android SDK, it consists of many Android libraries and some development tools. So it contains an emulator for testing your Android app. It contains Android libraries, specific components of Android, etc. So to check out the documentation and if you want to get some more info, you can go to http://developer.android.com and you can get more information from there. So let us look at the Android software stack. So the picture here, it gives you an overview of how the Android architecture is placed. So as you can see, it can be divided into 5 major divisions. So at the lowest level, it contains a Linux kernel. So the Linux layer, contains of the USB driver, which takes care of USB connections from the device. It contains a camera driver, which contains the driver functions for the camera, the Bluetooth driver, the display driver, the keypads, etc. So what features does the Linux kernel provide? It provides a security feature mechanism wherein one app does not have permissions to interfere with the operations of another app. It provides a power management resource, power management framework. Basically, since Android is based on devices which run on battery, so the Linux kernel takes care of the power management of the device. So it is a specially written management system, particularly for Android. It contains inter-process communication mechanisms called binders, which is again specific to Android. It contains all the drivers for other peripherals and I/O devices also. So this is the basic. It also performs memory allocation, process creations, and typically the basic things that an OS does. So it is the most bottommost component of the Android architecture, and it contains the Linux kernel. So on top of that, there are system libraries. So there is a WebKit library for entering web pages and displaying HTML pages. There's an SQLite framework for relational databases and handling in-memory database changes. There's a media framework which is used for playing back videos of different formats, videos and audios of different formats. There's OpenGL system for display rendering high-end graphics. The Surface Manager for the display of the phone, and there are another few more libraries which are basically native libraries uh, that are on top of the Linux kernel. So it also contains an Android runtime system. So Android runtime system consists of two parts. One is the core libraries, the basic core Java libraries, for example Java util and other basic libraries which you would use in a normal Java program. And it also contains a Dalvik virtual machine. So what is Dalvik virtual machine? So DVM or Dalvik virtual machine is basically a runtime environment which executes your Android app. So currently, it has been succeeded by its successor, which is nothing but Android runtime. So it is succeeded by it succeeds the Dalvik virtual machine. So why do we need a Dalvik virtual machine? Why can't the application which normally runs on desktop, it would be using a Java virtual machine, right? So why would we need a Dalvik virtual machine instead of a Java virtual machine? So basically, in phones, there will be many optimizations done, since it has a limited amount of memory and limited amount of power. So basically, DVM is a optimization which is specific for a phone, and it is targeted to run your apps to run in a constrained environment for like memory constraints and power constraints and some other constraints also. So that's why we need a Dalvik virtual machine instead of a JVM. So on top of that, there is an application framework which consists of an activity manager which manages all the activities of your app. It helps in managing from changing from one activity to the other. There's a package manager which keeps track of all the apps that is installed on a system. There is telephony manager which takes care of all the contacts and all the information related to making calls. This resource manager which keeps track of all the resources in your phones. So similarly, there's a content provider for sharing data across apps. There's location manager for giving you a set of locations from your device, the set of current locations of your device. There's notification manager which helps you in managing the notifications that come up on your phone. And there are also other frameworks like this on top of the libraries framework. So on top of this, the application framework, there are applications that you write and also the applications that come on your phone by default. For example, in your phone you get a dialer. So that is nothing but the phone application which is built in by default by Android. So there's a contact application in your phone which comes up by default. That is nothing but the contacts application which is listed over here. So this is the Android software stack, which is divided into 5, as you can see. So now we'll discuss how a typical workflow of your Android app takes place. So on a high level, you write the Android apps in the Java programming language. After that, they are compiled into Java bytecodes. So this is the typical flow in a normal Java-based application on desktop. The change over here is after your app is compiled to Java bytecodes, there's a program called DX which converts the bytecodes into a single DEX file, which will be called classes.dex. So this is basically an optimization to run on Android. So it is an optimization uh, compared to the normal Java workflow. And after that, the DVM, it executes your DEX files uh, uh, one after the other. So now, as of this writing, DVM is no more in development, and it has been succeeded by the next virtual machine, which is called Android Runtime. So, other than this, in a typical Android framework, uh, every app has a Linux user ID. So the applications in your Android app, they are stored in a multi-user Linux environment. So every Android app has a unique user ID, and none of they basically they run in their own sandbox, so that none of the Android app can interfere with someone else's Android app. If you want to do that, you need to specify some permissions wherein you need to interact with some other apps, and then the Android system provides you with the mechanism to do so. So every app in Android has a unique Linux user ID. So whenever an app is open in Android, a new process opens up and your app is run in that process. So if you want different apps to share data or interact with each other, if you want two apps to have the same user ID, then you need to sign those apps with the same signature. So this was a basic introduction to Android. I hope you liked it. And remember to like, share, comment, and subscribe to my channel.